In today's video, you'll be learning about imaginary numbers. Now, imaginary numbers are any numbers that are associated with I, okay? And they're called imaginary for a reason. For example, 4i plus 3 is an imaginary number because it's associated with the letter I. So, why is I referred to as an imaginary number? Well, we'll have to look at what I equals to know that. I equals the square root of -1, okay? So that's why it's an imaginary number, because you cannot take the square root of a negative number. So that's why, yeah, again, we refer to it as an imaginary number. So, but why exactly why is this helpful? Because if you want to take the square root, say -4, right? In order to take the square root of -4, we have to somehow cancel out the -1, right? Because this is equal to the square root of -1 times the square root of 4. So, but we can easily do this since we just said I, the imaginary number, is equal to the square root of -1. So this can be written as 2i. So I actually helps us to simplify square roots, or square roots that cannot be simplified using real world methods. Okay, now we'll keep on increasing the power of I and see what happens. Okay, I squared, what is I equal to? Well, since anything inside the square root raised to the second power equals whatever was inside the square root, then this must be equal to -1. Okay, because the square root of -1 raised to the second power, the square is going to cancel out, leaving you what was inside, -1. Now, I cubed, that's just going to be equal to -1 times I. So that just gives you -I. I to the fourth power, that's just going to give you, right, -1 times I. So right now you have I cubed times another I, so now you have I to the fourth power. But now, what is this going to equal to? Well, I times I is just -1, and -1 times -1 is just 1, so we have 1. Okay? Now, what is I to the fifth power? Well, I times 1, right? Previously we have 1, right? So I times 1 will just give you I. So that means I repeats itself every 4 cycles, because, right, we have 1, 2, 3, 4. So every 4 cycles it's going to repeat itself. Okay, now I'll give an some examples that you can do at home. Okay, so for these examples, try to do them by yourself and pause the video. Okay, now that you've given them an attempt, I'll solve them. So, you might be thinking, it's going to take forever just to go on and writing everything, right? All the I exponents up to 201 for the first one. However, we don't have to do that, because all we have to do, right, is this is like a cool symmetry trick you can do, okay? And all you have to really do is just divide 201 by 4, since I repeats every 4 cycles. So when you do that, you get a remainder of just 1. Let me just put remainder there to make it more clear. R1. Okay? Let me just make this more mathematically correct by putting, so 50, okay, yeah, remainder 1. There, it's more mathematically correct now. So 50, you get 50, remainder 1. Now, we don't look at the 50, okay? We only look at the remainder, which means that what is I to the first power? Because we're just going to be raising it to the remainder, okay? So what is I to the first power? Well, I to the first power is just I. So this is equal to I. That's all it is. Or you can also put the square root of -1, but it doesn't even matter. Okay? Now, we do the same thing for a second one. Divide by 4. Okay? And this gives you 8 remainder 2. Okay? Now, since the remainder is 2, what is I raised to the second power? That just gives you -1. So this is equal to -1. You do the same thing for the last one. 16 divided by 4. That just gives you that just gives you 4 remainder 0. So what is I raised to 0 power? Well, anything raised to 0 power gives you 1. So I say 16 power is just 1. So yeah. Now same thing for the last one. 14 divided by 4 gives you 3 remainder 2. And what is I raised to the second power? Well, that gives you -1. So these are all our answers. So again, I'll say the process again. So divide the exponent by 4, find the remainder, and raise I to that remainder, and you'll get your answer.